This is our speaker box rig demo, which is a vibration measurement demonstration or laboratory exercise. Here you can see our speaker box. We have a speaker, relatively low cost speaker cone mounted into this box, which is on rubberized feet here to prevent some vibration transferring into the table and vice versa, just to isolate it from vibration. There's a built-in amplifier. We can amplify our input signal in two ranges, 100 millivolts or 1 volt. So if our input signal is in the 100 millivolt range, then we would flick the switch up. If it's in the 1 volt range, we would have the switch down. We currently have an input signal which is coming from the oscilloscope here, which is in the 1 volt range. There's some power, which is just DC supplied to the speaker box for the amplifier. This is the oscilloscope here, and the yellow trace that you can see is our output signal, which comes from the oscilloscope over this cable. We also have a T-piece here, so we can take that signal direct. It's a voltage output signal. We can take it directly into channel 1, which is currently being shown in yellow on this oscilloscope screen, and you can see very nicely a sinusoidal signal here. We have other videos on how to use an oscilloscope. You can see that I can adjust the frequency here from low frequency, let's say for example in this case 20 hertz, all the way up to something like 300 hertz, and we immediately can hear the difference, and we can see the signal on the oscilloscope nicely here. Just going back to 20 hertz, you might be able to see the vibration of the diaphragm of the speaker. In terms of measurement transducers, here we have a laser triangulation sensor mounted to this bracket here, which is mounted directly to the speaker box. Essentially we have a laser beam coming out of this small box, an invisible laser, onto the top of the speaker, and that measures the displacement of that cone. And this is the green signal that I can turn on channel 2 on my oscilloscope. There is signal conditioning associated with this transducer here. Signal conditioner is sitting behind the oscilloscope, and we have a voltage coming to our oscilloscope that's proportional to displacement. A second transducer in use is this laser Doppler vibrometer, which measures velocity. Here we have the opportunity to adjust a number of settings, including the velocity sensitivity between 500 millimeters per second per 4 volts to 100 to 20. 20 being the most sensitive, 500 millimeters per second for a 4 volt output being the least sensitive. We can also change our device to introduce a low pass filter, which we can set to either off, i.e. 22 kilohertz, to 5 kilohertz, or to 1 kilohertz. And lastly, we have a high pass filter, which is basically either on or off, and is 100 hertz high pass filter. We typically would leave this on, such that these low frequencies, we can see them, we can measure them. And that's connected directly to, there's a voltage output. I've given the sensitivity, it's a 4 volt range. We have 500 millimeters per second in that 4 volt range. That transducer is connected to channel 3. Lastly, there's an accelerometer mounted directly to the top of the speaker cone, and that measures the acceleration of the speaker cone. Again, there is some separate signal conditioning. This is a IEPE transducer, integrated electronic piezoelectric transducer. It's provided with a bias voltage. It modulates that bias voltage as a function of the measurement of acceleration. And that's the 4th signal on our oscilloscope, which is here in magenta.